Now we're going to continue to the derivatives. This is the second part of chapter 18. Okay, what is the meaning of the derivative? Derivative means that you are getting the slope of the tangent line. For example, here you have a curve. This is the curve. When the line intersects the curve at 2 points, I call it secant. Okay, and once the line intersects at the curve with just only 1 point, I call it tangent line. So if I took the slope of the secant line, this means I'm getting something called the average speed. But if I'm taking the slope for the tangent line, this means I'm taking something called instantaneous speed or instantaneous velocity. So I'm just trying to get the speed or the velocity at a specific point, a specific time. This is called the derivative. So once you have something called the slope of the curve or the slope of tangent line, or I'm asking you to get the instantaneous velocity, this means that I'm asking you to take the derivative. So we have some rule for the derivatives. The first one is the constant rule, which means if you are taking the derivative for any number, this means it's 0. Here, function of x equal 2. This is a constant function. So if I'm asking you to take the derivative for it, it would be 0. So the derivative for any number would be 0. Second rule is the power rule. So here, for example, I have x power 3. I'm asking you to take the derivative. The power rule say drop the power and subtract 1. So I'm going to drop the 3 here. So 3x and subtract 1. So 3 minus 1 is 2. 3x power 2. What if I have a number besides x? For example, function of x equal 2x power 4. So you're going to multiply the power by the number besides the x, which is the coefficient. So 2 times 4 is 8. And you subtract 1 from the power. So it would be 8x power 3. This is the power rule. We have also the product rule. We use the product rule when we have to function multiplied by each other. For example, here, it's 3x multiplied by x plus 1. This is the function of x, okay? And I'm asking you to take the derivative for it. Of course, you could multiply or distribute over the bracket, and you could solve it without using the product rule, but sometimes we need to use the product rule maybe when we have like a trigonometric function or something that I cannot multiply. So I will just try to apply the product rule over this simple example. Here, it would be the first function. This is the first function multiplied by the second function, the derivative of the second function, plus the second function multiplied by the derivative of the first. Okay, here is the first function, f, and here is the second function, g. So let's try to apply the rule here. Where is the first function? It's a 3x. 3x. You just put it 3x. Now, take the derivative for g function, which is x plus 1. Okay, so what is the derivative of x? This is power 1, right? So you drop the power just 1, and you subtract 1. Here, x, it's power 1. If I drop the power, it would be 1. And if I subtract 1, it would be x power 0, and x power 0 equal 1. So 1 times 1 equal 1. So for you, the derivative of x is just 1. What if I have 2x? the derivative of 2x would be 2, because the derivative of x is just only 1. So the derivative of any number, it's just 0. The derivative for x is 1. The derivative of a number multiplied by x, like 2x, 3x, would be just the number without the x. So here it would be, here is 1. And if I took the derivative for 1, it would be 0. So 1 plus 0 give you 1. So I'm going to multiply it by 1 plus. Where's the second function? It's g x plus 1 multiplied by the derivative of the first function, which is 3x. What is the derivative of 3x? Would be 3. Then we simplify it. Here it would be 3x plus distribute 3 times x is 3x, and 3 times 1 give me 3. So 3x plus 3x give me 6x plus 3. Here is the product. Okay. Now we have also the quotient rule. Quotient rule when you have two functions divided by each other, when you have rational function. So let us try to apply the quotient rule over a simple example. Let me try to give it to you like this. Here I have 2x power 2 over x plus 3. I'm asking you to take the derivative for this. So here is the rule. You have to start at the beginning with the first function, which is g. This is g and this is f. So g multiplied by the derivative of the first function minus first function multiplied by the derivative of the second function over the second function power 2. Okay. Let's try to do this. So where is g? It's x plus 3. Here, x plus 3 whole to power 2. And let's start with the numerator here, x plus 3. Took the derivative of f. If I took the derivative for f, I drop the power 2 times 2, 4, and subtract 1, so it's 4x. Minus the first function, which is 2x power 2, multiplied by the derivative of the second function. What is the derivative of x plus 3? It's just 1. Here is the quotient rule. Okay, so the last rule that you would use, the square root rule, or when you try to get the derivative of a square root function. Let me try to make it easy for you. For example, I have the square root of 6x, and I'm asking you to take the derivative for it. So you're gonna take the derivative for whatever below the root. What is the derivative of the 6x? It would be just 6. Okay, you're gonna put just 2 here and the function. This is the derivative for it. Of course, you could simplify. So let's simplify. 6 divided by 2 give you 3. So it's a 3 root 6x. So the first step, you took the derivative for whatever below the root. Here's the number. Then you put 2 and multiply by the function you have. This is an easy way to get the derivative for the square root function. Let me try with something else with you here. What about the square root of x plus 3? Here, take the derivative for whatever is here. It's 1. Okay, 2 times x plus 3, the square root of x plus 3. Okay. Okay, let's try to solve some questions here. I have the function of x equal 4x power 2 plus 7x minus 3. So I'm just trying to get the derivative. It's just only power rule. So 2 times 4 is 8. Subtract 1, so it's x power 1. Any number besides the x would just be 7. So the derivative of 7x would be 7. Why? Because x is power 1. So if I drop the power, it would be 7. And 1 minus 1 give me 0. So x power 0 equal 1. So 7 times 1 equal 7. So that's why the derivative of a number multiplied by x is just the number, and the derivative of the x is just 1. And of course, the derivative of any constant would be 0, so I just neglect it. So my answer would be 8x plus 7. Okay, here, what is the derivative for a function of x equal 5? This is a constant function, just a number, so it's just 0. Now, the slope of the curve, y equal root 3x. Slope of the curve, this means I'm asking you to take what? To take the derivative. So let's take the derivative. Remember the rule for the square root? Take the derivative for whatever inside the root here. So it would be just 3, 2 multiplied by the function. So 3 over 2 root 3x. The slope of the tangent to the curve. This means I'm asking you again to take the derivative. So let's take the derivative here. This is 2x plus 2. Now he told me that the x equal 2, so I'm just substitute 2 times 2 plus 2 give me 6. Now, if function of 3 equals 7 and the derivative of 3 equals 4 and g of x equal x power 2 plus 1, then the value of f over g is the derivative of f over g of 3. So this means this is quotient rule because here I have a rational function here. So let me remind you with the quotient rule, it would be g multiplied by the derivative of the first function minus the first function multiplied by the derivative of the second over the second squared. So let me try to apply this rule here. Where is g? This is x power 2 plus 1, right? But he just told me that the x is 3. So I'm just substitute. So 3 power 2 plus 1. 9 plus 1 give me 10. So this means that g is 10. Okay. The derivative of the first function. What is the derivative here? It's 4. F, the first function, which is 3 equals to 7. Then the derivative of g. Let's take the derivative of g of x. It would be 2x. Then we substitute again. So 2 times 3 give me 6. Over the second function power 2. The second function here equals to 10. So 10 power 2 give me 100. So it's 40 minus 42 over 100. So it give me 2, negative 2 over 100. So it give me, if I simplify, it give me negative 1 over 15. So here's the answer. The motion of a moving object is given by s of t equal to t power 3 minus t power 2 plus t plus 1. What is the instantaneous velocity at t equal 1? Remember, I told you, when I told you I need the instantaneous velocity, this means I'm asking you to take the derivative. So let's take the derivative. Here, it would be 3 times 2 is 6, t power 2 minus 2t plus 1. And of course, the derivative of 1 here would be 0, so just neglect it. Then I'm gonna substitute because they give me t equal 1. So 6 times 1 power 2 minus 2 times 1 plus 1 give me 6 minus 2, 4. 4 plus 1 give me 5. If function of x equal 4 to the square root of x power 3 over 3 minus x, a rational function. Let's try to apply the quotient rule again. Remind you with the quotient rule. Here is it. Okay, here. So let's apply it. Three minus x all to power 2. The first step. Then g is 3 minus x multiplied by what? By the derivative of the first function. Let me take the derivative of this alone here. So 4 square root of x power 3. Okay, here I could handle this like this. I convert it to the power 4. So it would be 4 x to power 3 over 2. Right? Good. Now, let's just take the derivative. So it's 4 times 3 over 2 times x. 3 over 2 minus 1. It will give me 1 over 2. So let's simplify. It will give me 6 root x. Because I will convert again half here to square root. So this is 6 root x minus the first function, which is 4 square root of x power 3 multiplied by the derivative of the second function, which is 3 minus x. 3 minus x, the 3 here would be 0, and the derivative of negative x would be negative 1. So this is negative 1. Pay attention to the sign. After this, I'll just substitute. It give me that I need the derivative when x equal 1. So I'll just substitute. 3 minus 1 here times 6 square root 1 minus 4 to square root 1 over 3 multiplied by negative 1 over 3 minus 1 all to power 2. So 3 minus 1 is 2 times 6. Here it's 4 times negative 1. So 2 times 6 give me 12. 12 minus negative 4. 3 minus 1 is 2. 2 times 2 power 2 give me 4. So here 12 plus 4 give me 16 over 4 give me 4. So the answer is 4. What is the derivative of the function of x? Negative 7x power 2 plus 4 multiplied by 2 minus x. Of course, I could use the product rule, or I just distribute over the brackets and then take the derivative. So I will just distribute over the brackets. No need to use the product rule. Here, let me distribute. So negative 7 times 2 give me negative 14x power 2. Negative 7x power 2 times negative x give me positive 7x power 3. 4 times 2 give me 8. 4 times negative x give me negative 4x. Now let's take the derivative. Sorry, I forgot to do this. Yeah. This is power 2. Let's take the derivative now. So negative 14 times 2 give me negative 28x plus 3 times 7 give me 20x, 21x power 2. The 8, the derivative for it is 0. Negative 4x, the derivative for it, it's negative 4. So which of the choices matches my answer? This one. What is the derivative of the function? Again, this is the quotient rule. Let's apply it. Remind you the rule again. This is g. Let's apply it. So 5 minus 3x 4 plus 3x. Take the derivative of this one, it would be negative 3 minus 5 minus 3x. Take the derivative for this one, would be 3 over 4 plus 3x all to power 2. Now let's try to simplify. Or let's distribute over the bracket. Negative 3 times 4 give me negative 12. Negative 3 times 3x give me negative 9x. Okay. I will just distribute. So 3 times 5 give me negative 15 minus 9x over 4 plus 3x all to power 2. Of course, minus minus would be positive here. So it would be here negative 15 plus 9x. So a negative 9x canceled with positive 9x, and I still have negative 12 minus 15. So it will be negative 27 over 4 plus 3x all to power 2. So here's my answer. If function of x equals 3x power 2 minus x power 3, then the maximum value of the function on the interval 0 to 3 is. Okay, to explain this to you, I'll just explain something, then we try to solve this one, okay? So here, I have a curve. Here, I have this point, and I have this point, and I have this point. For me, this is the maximum point I have in the curve. I call this maximum value. And this is the lowest point I have in the curve. So I call this minimum value. Or minimum point. Okay. At the maximum and the minimum, your function is changing the direction. So maybe it's decreasing or maybe it's increasing. For example, here, it was increasing, then it's decrease. So there is a change in the direction. Again, it was decreasing, then it's increasing. Then, again, it's decreasing. So at the maximum or minimum points, there's a change in the direction. If it's maximum, then it was increasing, then decreasing. If it's minimum, this means it was decreasing, then increasing. So I call this the changing point or sort of inflection point. To find this point, I have sort of steps. So let me write the steps with you here to find the maximum and the minimum point. I call this one absolute maximum. Why I call it absolute maximum? Because this is the highest point of the graph. I call this one local maximum. It's maximum, but at sort of interval. So at this point, this is the absolute minimum because this is the lowest point on the curve. So maybe I have local maximum, maybe I have local minimum, maybe I have absolute maximum, maybe I have absolute minimum, maybe I don't have. Okay, it depends on the curve. So when I'm asking you about the maximum value, we have some steps to do. So I will explain the steps for you now. The first step here to take the derivative. Number 2, to solve for x. Number 3, substitute in the original function. Now, at the maximum and the minimum point, the derivative all the time would be 0. So at maximum and minimum points, the derivative of x would be 0. So that's why I'm going to solve the function. So let's take the derivative first. So here's the derivative equal 6x minus 3x power 2. Then I will put it equal to 0 to try to solve it. So here I'm gonna take 3x as a common factor. So it would be here 2x minus 2 minus x equal to 0. So maybe here's the x equal to 0, or maybe x here equals to 2. Then I have to substitute. I'm gonna substitute in the original function here. Take these values and try to substitute. So the function of 0, if I put 0 here and 0 here, it would be 0. And if I put 2, so here, 3 times 2 power 2 give me 2 power 2 is 4. So 3 times 4 is 12. And 12 minus 8 give me 4. After I finish this, I have also to substitute the interval or the given points that give it to me. I call this endpoints. So I have also to substitute it. Of course, I substituted the 0 and I substituted the 2 because it belonged to this interval. So I have also to substitute the 3. Let's get the function of 3. If I put instead of the x here 3, so 3 power 2 minus 3 power 3. 3 power 2 is 9, 9 times 3 is 27, and 3 power 3 is 27, so 27 minus 27 give me 0. Now, let's compare the values. Where are the maximum value here? The maximum value is the answers here. Where is the greatest answer you have? The greatest answer you have is 4. So my answer is 4. So the maximum value is the y value, or after you substitute the x, you get this value. So here, this is my maximum value. So to get the maximum or and minimum values, absolute maximum or absolute minimum, you have to take the derivative, solve for x, then you substitute. What is the sixth derivative of the function? Okay, here I'm asking you to take the derivative 6 times. This will take a long time from you, but here's the trick. I will check what is the greatest power I have. The greatest power I have is 5. Now, he told me I need the 6th derivative. So this means it's greater than the power. So if it's greater than the power, this means it's 0. If you notice something, when we take in the derivative, this means that you are decreasing by the power each time because you subtract 1. For example, this was x power 3. If I took the derivative for the first time, it gives me 3x power 2. So I decrease the power. If I took it again, it would be 6x. If I took it for the third time, it would be 6. If I took it for the fourth time, it would give me 0. So every time you take the derivative, you decrease by the power. So if the derivative he asked you to get is greater than the greatest powers you have in the question, so the answer would be 0. If the function of x is continuous in the interval 0 and to 12, increasing on 0 and 5, and decreasing on 5 and 9, then the function of x has a local maximum at. Okay, we agreed that when I tell you maximum or minimum, this means I'm having a changing point. This means I was decreasing, then increasing, or increasing, then decreasing. So where is the point that you have changing the direction? It's repeated here, the 5. So at x equal 5. If the function of x is continuous on R and has a local maximum at x equal 1, and a global maximum at x equal -2, which of the following statement must be true? So the maximum point when x is equal to 2, and the lowest point would be at x equal 1. So the first one, the function of -2 greater than the function of 1. Of course, if I say global maximum at 2, this means the function of x would be the highest point on the curve. So this means that the function of -2, yes, should be greater than the function of 1. Function of 1 equal to function of -2, of course, no. This one is maximum and this one is minimum. The function is decreasing on all of R. If it was decreasing, there wouldn't be a global maximum or global minimum. We have both local minimum and the global maximum. The function has no critical points. Actually, we have two critical points there, local maximum and the global maximum. Sorry, local minimum and the global maximum. So the critical point also, or the maximum and minimum points, I call it critical points. So only choice here is the function of -2 is greater than the function of 1, because as the global maximum, I have the highest value for the function. Use the second derivative test to determine where the function has a local maximum and a local minimum. Second derivative test means that you're gonna take the derivative for the second time, but we have interpretation after we take the derivative or the results of the derivative. If the result of the derivative was greater than 0, this means that you have local minimum. If it's smaller than 0, so it's local maximum. Okay, if it's equal to 0, it's inclusive and I cannot consider it as local maximum or local minimum. So let's try here. So we're gonna follow the same steps I explained it before. Here, let's take the derivative. So 3x power 2 minus 6x. Then we're gonna put it equal to 0 because we know that this point of the derivative would be 0 to solve for x. Then I'm gonna take the 3x as a common factor, so it's x minus 2 equal to 0. So maybe x equal 0 or maybe x equal 2. Now, I'm gonna take the derivative for the second time. So here it would be, let's take the derivative 6x minus 6. Now, I'm gonna substitute these values on the second function. Let's substitute. So 6 times 0 minus 6 give me -6. And let's substitute the 2. So 6 times 2 minus 6 give me 6. So at 0, it gives me -6. So it's smaller than 0. So at 0, you have local max. And at 2, you have local minimum. So he tell me maximum first, then minimum. So it would be 0, then 2 here. Here's my answer. I hope you understand it very well.